Today in this class, let me discuss the inference theory in mathematical logic. So you see that I will take up the second problem here first to explain to you how to arrive at a conclusion based on the compound propositions given to us and applying the tautological implications, equivalences, and also the propositional algebra to the given compound propositions. We can call the compound proposition as premises also. We call them as premises. We can call the compound proposition as premises. In simple words, a compound proposition is one in which there will be two or more atomic propositions will be there, and they will be connected by the or and or the negation. That means if P is a atomic proposition and Q is another atomic proposition, now this is a compound proposition. P implication Q or negation P implication Q, these are all called the compound propositions or the premises. Now these premises will be given to you. Now based on the, as I told you, you have to apply all these tautological implications, apply them on the compound propositions and arrive at a conclusion. You infer something from your argument. This is just like a lawyer doing his argument based on the evidences and the witnesses, that is statements given by the witness or the convicts. So it's just like that. So you see that here the statements will be given. They are called the hypothesis or the compound propositions or the premises. Based on that we arrive at a conclusion, and that is called how we infer. We infer certain things from the given premises by applying the what? Rules. Okay, now this is what I am going to do, and let us see for this first problem. Let me take second problem. In the second problem it is given that if it rains heavily, so I will call this as P rains heavily. So what is that? Rains heavily. So my P will always, if I write P, you must understand that it rains heavily. And Q, here then traveling will be difficult. Traveling is difficult. Then R, students arrive on time. Students arrive on time. So you see that where P means rains heavily, Q means traveling is difficult, R means students. Here I have written here students. Students arrive on time. Now these are the three premises that are given to us, and now we have to form the compound propositions. See, if it rains heavily, then traveling will be difficult. See, I write here P implies Q. Now read this. If it rains heavily, traveling will be difficult. This first compound proposition. Then the second one is if students arrive on time, then traveling will not be difficult. If students arrive on time means what? So students arrive on time, then traveling is not difficult. So you read this. If students arrive on time, traveling is not difficult. So traveling is not difficult means the students have arrived on time. Now what the next one is given is that difficult. They arrive on time. The students arrive on time. That is R. Now these three are your compound propositions or premises, and you apply your logic on this, applying all those equivalences and tautological implications and use these premises and arrive at a conclusion, and that conclusion must be what he tells is that it did not rain. That means what? If you apply the rules of logic or the equivalences, tautological implications and algebra of propositions, apply them to these three premises in all possible ways and arrive at a conclusion, that and conclusion should be negation of P, that is, it did not rain heavily. This is what we do. Now for this we prepare a statement like this. That means we prepare a statement like this. It is serial number and it is a statement and a reason. I'll tell you what it is. First one, see, what we do is we make the argument, we place our argument based on what is given in the problem. So here you see that I will take up the first one. It is given that P implies Q. So this is the premise that is given to me. If it is given to me, if I take a premise given in the problem, I will use a rule called P rule. This is called your P rule. What is meaning of P rule? P rule means if you are using a premise for your argument from the problem, it is called a P rule. Are you able to understand? So P rule is one where you use the premise that is given in the problem for your argument. Okay. Then now number two, I will write it here, that here you see that I will write this as negation Q implies negation P. Here you see that this is not given in the problem. This is not given in the problem. I arrive at the problem based on what is given in the problem. I arrive at certain conclusion. I arrive at a statement which is in no way contradicting my preceding statements. What is that statement given here? P implies Q. But I write it as negation P implies negation Q. This is true. This is true. From where it comes? It comes from 1, because it is called the rule contrapositive. It is called contrapositive. I'll write it as positive itself. That is, P implies Q is identically equal to negation Q implies negation P. This is called your contrapositive rule. So I have used. Now, so this T means, if I write means, it means I am arriving at a particular statement based on the preceding premises given in the problem, or otherwise applying my tautological implications and equivalences. By tautological implications, I mean, see, for example, you see, if P is true and P implies Q means this tautologically implies that Q is true. A statement, if you are given premises and based on the premises, if you are able to arrive at a tautological statement, tautological means true statements. You arrive at a statement, you are based on applying the logic, you arrive at a statement, such statements will be tautological implications. That means what? It is true. Tautology means true for any value of the variables. So it is true. So this is, you see that P implies Q means it is tautologically true that negation Q implies negation P, or we call it as equivalences. Here you see that this is contrapositive equivalences. Equivalence means they are equal. P implies Q is identically equal to negation Q implies negation P. So this is the meaning of that. Then next one is 3. I will use, what is that here you are having? So R implies negation Q. This is given in the problem. Now you see that this is given in the problem, therefore I use the rule P. Then 4 I will write here. See here, R implies negation Q. Negation Q implies negation P. Okay, so what does it mean? So here you see that it is, see, R implies negation Q and negation Q implies negation P means R implies negation P. Now this is true. I am arriving at certain conclusion based on the preceding premises. So you see that this is 2, and here all what? The statements that have been used based on the preceding statements, I am able to arrive at a certain conclusion. What is that? Here I have taken R implies negation Q, and negation Q implies P means R implies. This is true, and it is coming from 2 and 3, and this is called hypothetical syllogism. What is that? If P implies Q and Q implies R, then P implies R. R implies negation of P. See, R implies negation Q implies negation P means R implies. And next one, your R is true given in the problem. Your R is true. Now you see that R is true. See, read this. R is true. R implies negation P is true. Therefore, negation P must be true. That means your conclusion here. So here R is true. R implies negation P is true. So negation P is true. This is true, and it is coming from 4 and 5, and it is called, the rule is modus ponens. Modus ponens means what? Here modus ponens, here it is, if, see, P is true and P implies Q implies P is true and P is true and P implies Q is true means Q is true. This is called the modus ponens rule, and I apply that here, so I am able to arrive at this negation P, and you have to see that I have used all the premises to arrive at negation P. So negation P means what? The students arrive on time, and it was not raining heavily, so that it is true. Whatever the conclusion arrived at in the problem is true only. So this is how we do the problem on inference theory. That means what? Given the premises, we apply our knowledge of tautological implication, equivalences, and arrive at that. See, implications, I will tell you what does it mean. See here, so this problem is over, and you see that equivalences means, I will tell you what is the meaning of equivalences, because you should know. See, this is what I mean by this. See, if it is P implies Q is equivalent to negation P implies negation, this is called your equivalences. So you see that, and total this if P is true and P implies Q true means Q is true. This is called tautological implications. P is true and P implies Q is true, therefore Q must be true. So it is implying tautological implication means what? It is definitely true that if P is true, P implies Q is true means Q is true. And P intersection means if P is true, P is true, P intersection is true means Q must also be true. Only when both are true, P intersection P is true, Q is true means what? P intersection Q is true. So these are all called conjunction. Likewise, we have got, I will give you the list in the next class. By the side I will write and explain certain things on that. So these are all called equivalences and tautological implications. We apply these ideas on the premises and get the answer. Now this is how we do the problems, and the second problem is over. And coming to the first problem, see, what does the first problem say? Your first problem, it tells you that prove that C R intersection P implies. So this must be a valid conclusion. This is a valid conclusion from the premises. It is disjunction Q implies R, P implies M, negation of M. This must imply R intersection P union Q. We must be very careful in writing this, otherwise you will get it wrong. So this is what. So I am going to explain the same, that is method will be the same, but I will tell you the approach. It requires a lot of logical reasoning and application of the rules, so that you will arrive at the answer. So you see that. So this is given to you, this is given to you, this is to you, and this is also given to you. You apply your rules or the laws, apply on these premises and arrive at this conclusion. Are you able to understand? Now let us go one by one. Say, I'll write it here. Serial number, statement and reason. First one, let me take. I will take this P implies Q. What is the law that you will apply here? It is your P rule. What is the rule? P rule. Then second one, let me take. I'll take this negation M. See, I will write immediately. I'll write immediately here. Say, what does it mean? I'll write here negation P implies negation. This is true coming from this because it is equivalence. Contra positive. It is equivalence. Okay? And the third one, take this negation M. It is given in the problem. Now fourth one will be, see, negation of M is true, negation M, negation P is true. This implies negation P is true. And this comes from 2, 3, and it is modus ponens. That is, P is true, P implies Q is true, implies Q is true. This is called your modus ponens. Then, fifth one, let me take. What is that I'll write? P union Q. This is your P. Sixth, I'll write here. This can be written as, this is true and it comes from 5 equivalence. P disjunction Q is identically equal to negation P implies Q. See, what does the negation P implies Q? It is equal to your PQ. Negation of negation P. See, here it is what? Negation of P union Q. This is your P and this is your Q. So this is what? So instead of this I can write this. Then 7. Negation P implies Q. Negation P is true, therefore Q is true. Negation, this is true. It is coming from 4 and 6 and it is. That is, negation P is true, negation P Q is true, this implies Q is true. Then, say I have used this, I have used this, I have P, I have used this, okay? Then, you see that, then the last one left is Q implies R. So Q implies R. This is given to you. Q is true and Q implies true. This R is true. This is R is true. This is your truth. It is coming from 7 and 8. Modus ponens. See, it is what is that? Q is true. Q implies R is true. This implies R is true. Now you see that here, what is that you want now? R intersection. R is true. And here you see that P union Q is true. This is true. This is P union Q is true. R is true. See, I will write here. So 10 is R intersection P union Q is true. It comes from 5 and 9. See, R is true, P union is Q is true, therefore this is true and this is also true, and therefore R intersection P union Q is true. This is coming from 5 and also 9, it is conjunction. So what is the meaning of conjunction? If P is true, then Q is true, then P intersection Q is true. R is true, P union Q is true, therefore R intersection this is true. So you see that P implies Q, I have taken this premise, then I have used the contrast or positive idea, negation M implies negation P, negation M is given to be true, therefore negation P is true. Then I have taken what is called P union Q, P disjunction Q, this is equivalent to negation P implies Q. That means what? Your negation P implies Q, negation P is true, therefore negation this is true. And you are given that Q is true, Q implies R is true, therefore your R is true. Now you see that you are getting it as what? Your R, therefore your R is true, but you are given that P implies union Q is true, therefore R intersection P union Q is true. So this is how we do this problem, and this problem, second problem, is over. Now let me come to the last one. So this is all about the second problem. Third problem, you see that here you must show that these are inconsistent. You must prove that this, what are the given premises? A implies B implies C. Next is D implies B conjunction negation C and A conjunction D. You must prove that these three premises are, that means if you call this as H1, then H2, then H3, then you see that H1 intersection H2 intersection H3 will lead you to a contradiction. It will lead you to a contradiction. It must become F. It is a if it becomes a contradiction, then I must say that they are contradict. That means what? One does not talk about the truth of the other. One premise, you cannot arrive at any statement of yours which can give you a truth value to the what? That means the premises are of they do not speak the truth, actually speaking. So if you connect these to use all these premises, you will end up with only what? A contradiction. You will end up with a contradiction. Therefore we say that what? The premises, they are inconsistent. So we say that the given premises are inconsistent if H1 intersection H2 intersection H3, like that, it turns out to be a contradiction. Let us see whether it is a contradiction here. Okay. Now what is that you get here? Serial number, statement, reason. Now let me write here. First one is A implies B implies C. So this is your P, it is given here. Then number 2, A intersection T, that is given. Number 3 I will write. As I told you, A is true. It is, whatever given in the problem is true. Take it from me. So A intersection D is conjunction D is true. So A is true. It is coming from 2 conjunction. And number 4, D is also true. It is also true. It is coming from this and for the reason. Now you see that here I will write something here. B implies C is true. It is because it is true because from it is coming from 1 and 3. That is, A is true. A implies B implies C is true, and therefore why it is coming from using 1 and 3, and it is modus ponens. That is, P implies Q. Here it is like this. P is true. P is true. It is like this. P is true, and P implies Q true implies Q is true. So that is what I have written here. Then here let me write here. So what is that here? D implies B conjunction negation C. This is given in the problem. So I have used this premise, this also, this also. Now what is that 7 I will write? See here again, D implies this, D is true and this one. So I will write B conjunction negation C is true. It is coming from 4 and 6. It is mode exponent. Q is true. Now what do you have here now? So here B implies. See here I will write here. So this is what is that you are having here now. So B implies C, I will write here. So this B implies C means what is that you will have now? So this is negation of P, C. See, this is true and it is coming from 5. It is equivalence. Because we know that P implies Q is equal to negation P union Q. So we are getting this statement. So you see that now you have got this 7 and 8. 7 and 8. Now here you see that B, here again, yes. B intersection, see what is that you get here now? So I will write this as your 9. Here negation of so I write this as negation of B intersection C. So I will write this 9 as this is negation of this is true. It is coming from 8 equivalence. Because you see that I have got here negation of P union C. This can be written as negation of B intersection negation C. You apply the De Morgan's law, negation B, this disjunction, conjunction will become disjunction. It is negation of negation is C. Can you catch this? See what I do here is that instead of writing this, I give the equivalent. What is that equivalent that I will write here? It is true. This can be written as negation B of this, because this is nothing but negation of B is negation B. This the conjunction will become disjunction, negation negations. So this is the equivalence here. This is what we have. Now 10. Now you see that this is true. See B intersection negation C is true and this is also true. See, I will give you the logic here. By 7, B conjunction negation C is true. By 9, this negation of that is also true. That means what? What do you get here is B, see, B conjunction negation is true. See, B conjunction negation is true. This is true as per 7. Okay, then and negation of B conjunction negation is true. This is because of what? 9. This B conjunction negation is true, but we have arrived at another true statement. Negation of this B conjunction is also true, and this comes from 7 and 9. It is applying what? Conjunction. What is conjunction law? P is true and Q is true means what? P must be true and Q must be true. P in conjunction Q true means P is true and Q is true. So this statement B conjunction negation is true, and we are able to arrive at another statement negation of. So you see that they both are same quantity. You just see that this and this. If you call this as X, what is that you get here? X is true and negation of X is also true. You see what is it? X is true How is that the negation of that x can also be true? Only one of them must be true. It is true. I teach in the class means I teach in the class and I don't teach in the class. Both cannot be true. Both cannot be true. So likewise, this statement is what? B conjunction negation is true. And again, I have got another statement telling me what? B negation of C. I am getting another statement. B conjunction negation is true. B conjunction negation is false. I am telling at one place B conjunction negation is true. But I am able to arrive at another conclusion. Negation, that is B conjunction negation is also false. So that means what? This is a contradictory statement. That means this is F. So I am arriving at a contradiction that it means that the premises that are given here are, it is just like a person, one who is giving some, he is a witness or somebody in a court. He at one time he says something, at another time he contradicts himself. He says something else. He says that I have been in that place. Another time he says that I was out of station, I was not there. So likewise, contradictory statements are given. So if that is given, that means what? His statements given by the witness or whomsoever be, they are all inconsistent. That means what? One does not go with the other and they are inconsistent, and that cannot be taken. So you see that likewise, these three premises that are given here, one more premise was that. So these premises given here, see, 1, 2, 3, they are all inconsistent because the conclusion I am getting it is F. They are contradictory. See, H1, H2, H3, they lead me to a what? R, and that R is nothing but what? They lead me to R, which is nothing but R intersection negation R, which is a contradiction. And therefore this. So this implies that. So let me conclude. So this implies that are inconsistent. So they are inconsistent. So here we are able to, if you see, we can do more problems on this, and I will take up some other difficult problems in the coming days. Thank you.